Hello, I'm trainer Tajeddin Benissa. I'm trainer in geology science. I welcome you to RCM course, which is the Reservoir Characterization and Modeling. The main target of this course is to enable geologists, reservoir engineers, and geophysicists to build an inclusive geological concept for hydrocarbon reservoirs. The detailed targets, which represent the benefits that the trainees will get right after the end of this course, included in five detailed targets or objectives. The first objective is to teach trainee how to analyze data from different scientific sources important for studying hydrocarbon reservoirs. Objective number 2 is how to integrate and interpret data to reach a clear conclusion about the type of the reservoir rock, and the objective number 3 is how to evaluate the reservoir quality in terms of petrophysical properties. Objective number 4 is to teach how to characterize and build a static model for each part or element of the reservoir, including structural element or structure model, stratigraphic model, and petrophysical model. Objective number 5 is to teach trainee how to calculate hydrocarbon volumes in place. So today we will start with we will cover the outlines that talk about the first objective, which is analysis or analyzing the data from different scientific resources. The first subject we will talk about is the types of the data that is used for studying and evaluating hydrocarbon reservoirs. There are 5 types of data used for studying reservoirs. The first one is seismic data. The second one is laboratory data, and the third one is well data. Number 4 is subsurface geology data, and number 5 is information or data from field surveys. So now let's start with the first subject, which is seismic data. What is seismic data? Seismic data can be represented as the scanned image or the negative carbon image for the structure and stratigraphic architecture subsurface. It's the data that we obtain from seismic reflectivity surveys. This data is very important because it provides a lot of information about the types of the structural subsurface, if we have a hydrocarbon trap or no, if there are faults or fracture networks. It also provides good information about the stratigraphic architecture. By obtaining this seismic data, we can determine or measure the size of the trap, determine we can measure the size of the hydrocarbon trap, determine the number of the faults, and also measure the depth angle and extension. Also, we can identify other structural features such as salt domes or reef buildups. And also we can calculate stratigraphic thickness and identify chronological relationship. The seismic data is obtained through 3 different working stages. The first one is seismic data acquisition. In this phase or stage, the first stage is recording waves that transmitted from certain devices on the ground, and these waves travel through the subsurface layers, and when it bounces and different dip angles, they are recorded using certain devices called geophones. After that, we move to the second stage or phase, which is seismic processing, which is converting these waves that received by phones into amplitudes, and from amplitudes to synthetic seismogram, and from synthetic seismogram we produce seismic cube in time that can be later converted into seismic in depth. Using this seismic, the geophysicist or the geologist can do seismic interpretation, which is the last stage of obtaining seismic data. So he or she can do the interpretation. So he can pick the seismic horizons, which is the top of the beds. Also identify the structures such as faults, fractures, whatever. After we had been through the seismic data, let's move now to the laboratory data. Laboratory data can be described as the laboratory data obtained in clinics. When the doctor, when some patient go to a doctor and ask for medicine, the first diagnosis that the doctor suggests is to move. The first step in the doctor's diagnosis is to ask the patient to do a blood analysis. So why do the doctor needs a blood analysis? To identify the disease from the effect that the disease or the virus done on the blood components or elements. It's a similar story with the hydrocarbon reservoir. We extract rock samples from the reservoir, send it to the laboratory to identify rock components and the diagenesis or the changes that occurred and affected the rock components and impacted or affected negatively or positively the properties of the reservoir. There are main two types extracted from the borehole or the well during drilling. First one is the core samples, which is extracted from certain depths and sent to laboratory to measure the most important petrophysical properties such as porosity, permeability, and water and fluid saturation. These three properties represent the most important properties that control the quality of the reservoir and its productivity. There's another analysis, the second analysis, lab analysis, which is the microscopic analysis. In this stage, we extract rock samples and we send it and we convert it into thin section. We put we study these thin sections under microscope to identify the components of the rock, the visible porosity, and the most important diagenetic process or the diagenesis that affected the rock after, during or after deposition. So now let's move to the third type of the important data that we need for studying and evaluating hydrocarbon reservoir, which is the well data, and I mean here the well logs. So what are the well logs? It's curves. It's curves that reflect certain values obtained by devices scanning the borehole from the top to the bottom, containing transmitter and receiver, and the transmitter emit electrical waves or electromagnetic or emit ions. These waves will be will be reflected by the particles or particles of the rock and recorded by the receivers in the same device during scanning from the bottom to the bottom along the borehole, and we will get curves, and these curves by the geologist or the petrophysicist can do the interpretation to reach conclusion about the lithology and the petrophysical properties and also the thickness of the beds around the hole. The well logs represent, it's very important data because it's we use it to calculate the hydrocarbon from oil and gas in place. Now, after we finished now with well logs, let's move now to the subsurface geology data. It's the data or the information that collected from subsurface studies such as stratigraphic study, sedimentological studies to identify depositional environments, correlation, chronological correlation. All this data can be of benefit to understand the thickness distribution, the change in phases, and the change in phases for the oil-bearing stratigraphic layers. Also, the field surveys provide good information about the reservoir by doing a correlation between the well section and the exposure and the rock exposures around the field to understand the change in phases and the thickness of the reservoir away from the borehole.